Alrighty then, looks like everything should be pretty good. So, hello world, Noah here. This is a live stream. It's the first time I've done a live stream in a little while. So if you're watching this video live, please bear with me a little bit. I know there's going to be a delay on the video, but I have the comments up on my second screen and I can see them. And if you're not watching this live, you're watching the recording of it, then hopefully it turned out well. Hopefully it's good. So in this video, as the title suggests, I'm going to be going on the website CodingBat.com. This is a website that I used to go on a lot back in high school. They have a pretty small collection of coding problems, but they're pretty solid coding problems, and the platform is very nice and simple. So if you use something like LeetCode or Code Wars, this is a very much simplified version of that. But it's a great website. And so I'm just going to go in here and solve all of the Python problems, or more specifically, these logic 2, string 2, and list 2. All of these other categories, these other 5, are like really basic. They're really not going to be interesting. So I'm just going to skip them, but I'm going to solve the interesting ones. And my goal is to solve all of them in one line, which has sort of become a theme on this channel as of late, I suppose. And by one line, I mean, of course, one expression, right? So some things like if statements and function declarations and all of that are out because, that would count as sort of its own statement. And so I'm sort of limited as far as what I can use in order to do this, but it makes the problems more interesting. And Python has a lot of tools that will help us out with this. And so just to show you really quick, this is my personal account. So I went through and I said I used to do this a lot. So I solved most of these Java problems. I think these map ones are new. I didn't solve them. And then the Python ones, I did go in and solve all of these Python ones a couple years ago, I think. But I just went ahead and registered a new account today. So we're going to start from scratch and we're going to solve some problems. I'm going to explain what I'm doing as I go through. Hopefully it makes sense. If you're watching this live, feel free to ask any questions, clarifications about the code, about whatever. And whether you're watching this live or not, let me know if you're interested in this sort of one-line, like sort of puzzle coding kind of stuff, because I'm personally really interested in it. I think it's a lot of fun. I've been doing a bit of it on the channel, but I don't know. If you're interested in it, just let me know. Without further ado, we'll get started. I'm going to start with logic 2. And you can see I've looked at some of these problems. I just went back and looked at a couple of them just to see. But we're going to do all of them from scratch. And so we'll go ahead and get started. I see there's 2 comments. So Adam Yaris says, "What's up?" So, and then Epic Ness of Game Knobs says, "I haven't seen you in so long." It has been a while. I think it's been about a year since the last time I've uploaded, but I'm trying to do a little bit of stuff now because I have some time. I think we all have some time, free time, so just trying to make the most of it. Anyways, let's take a look at this first problem. It's called make bricks. It says we want to make a row of bricks that is goal inches long, so that's our parameter goal. We have a number of small bricks, 1 inch, and big bricks, 5 inches. Return true if it is possible to make the goal by choosing from the given bricks. It's a little harder than it looks and can be done without any loops. Okay, shouldn't be too hard for us. All right, so the basic idea is that we have like these 2 measures, 2 bricks, one's 1 inch, one's 5 inch. We have some number of them, and we just want to determine if we can make, something that's goal inches long. And so the first thing obviously is if the bricks aren't long enough, if we have one big brick and we want to, the goal is 6, well, we can't, we only have 5 inches, and the goal is 6. But let's say the goal were 6 and we had 2 big bricks. Well, we could do 5 or we could do 10, but we can't do 6, so that wouldn't work either, right? And so this problem is pretty easy. The basic idea is that you want to use as many big bricks as you can, and then whatever is left that you need to do, you just make sure you have enough small bricks, right? Because the small bricks are 1 each, so you can always just, each brick increments by a unit of 1. If it incremented by 2 or 3 or something else, it might be a little bit trickier, but it increments by 1, so it's as precise as we can get, really. Anyways, so basically, again, the idea is that we just want to have our goal, and we want to see if we can do this. So all we need to do, really, and again, this is going to be one line, so all of our implementations are going to start with the word return for our one line. We're going to return, so the first thing is, if we take our goal and we subtract 5 times big, right? So big is the number of big bricks, and so if we do 5 times the number of big bricks, that would be like the length, the total number of inches that we have out of all of the bricks. And so if we take our goal and we say, let's say we use up all of the big bricks, right? Then we could end up with a negative number, which, actually, wait, we need to do this a little bit differently. What we need to do is, we don't want to end up with a negative number. What I said is we want to use up as many big bricks as we can. And so if for example, if the goal were 6, we would use 1 big brick, because a big brick is 5 inches long. And so we want to subtract basically either goal or 5 times big, right? So if we have, well, I guess that's not quite right. We'll fix the implementation a little bit. And I think this problem is actually going to be trickier than some of the other ones. But basically, we want to subtract some number of big bricks, but we don't want to go over our goal, right? Because we need to make sure that we have the small bricks that we can use. And then all we need to do is we just need to make sure that our goal minus the amount of the big bricks is whatever's left. We need to deal with the small bricks there, right? And so we just need to make sure that we have enough small bricks. And so I think this is not quite going to work, but just to sort of take a look at what CodingBat looks like if you haven't done it before, is you can see that it gives you a lot of test cases. There's a couple here, but it gives you a bunch of test cases over here. Gives you the expected output. It'll give you your output. If there's errors, it will show the errors, and then you can you can see your result. You can see if you got it right or not. And so let's go ahead and fix this now, because obviously it's not quite right. And so the problem that we need to fix is we want to subtract from our goal so we want to subtract from our goal 5 times the minimum of either the number of big bricks or the integer division of goal divided by 5, right? So let's figure out why this works. So if we look at this min value, right, if let's just say, and in the normal case, right, if we have, let's say that the input is, like here, let's take a look at this first case right here. We have 3 small bricks, we have 1 big brick, and our total amount is 8, right? So what we would do is we would say we want to use this big brick, which is 5 inches, and then we want to use 3 of these small bricks, which is 3, so 5 plus 3 is 8, so that works. And so in the normal case, we would just want us to do 5 times the number of big bricks, right? 5 inches per brick times the number of bricks that we have. But we could end up with a case where we have too many of the big bricks, or we have more big bricks than we need. And so, for example, right here in this case that I have highlighted, we have 2 big bricks, but our goal is only 8. So if we used both of the big bricks, we would end up with 10, but our goal is actually 8. And so we need to handle for that in this case. And so basically what we do is if we do the integer division of goal integer divided by 5, that will tell us the number of big bricks that we can use, the maximum number of big bricks that we can use. So for example, in the case of 8 integer divided by 5 is 1. right? It's 8 divided by 5 is 1 point something, so the integer part's just 1, which means that we can use at most one big brick on that 8, which makes sense, right? One big brick is 5, and then we could use 3 other ones. And then in the case of 10, the 10 divided by 5 is 2, so we could use 2 big bricks to make the 10. Or we could use 1 big brick and 5 small ones, or 0 big and 10 small ones. But the idea is that the maximum number of big bricks that we can use is goal integer divided by 5. So hopefully that much makes sense, right? And so the idea is that we can use as many of our big bricks as we can up to this point. But if we don't have quite enough big bricks, then we'd have to take into account the small bricks, right? And so this will tell us, this part, the min part that I've highlighted, will tell us the number of bricks, the number of big bricks that we're using. We multiply that by 5 because each brick is 5 inches, and then we subtract it from goal. So basically what this highlighted part will tell us is the number of small bricks that we would need. And so we just need to make sure that the number we would need is, I think, greater than or equal to the number of small bricks that we have, or is it less than? I might be thinking about this the wrong way. I think I am. It's definitely one of these sort of combinations. Okay, so it's less than or equal to. You can see it's all correct. So basically the idea is that this tells us, of course, this tells us how many small bricks we need. We want to make sure that the amount that we need is less than or equal to the amount that we have. A little bit out of my streaming practice here, but that's okay. We got this first one. So that's it. And then when CodingBat, when you're good, you'll see this all correct here. There are some other tests that it runs that you don't get to see. But we got this one correct. If you solve it and you get some test cases correct, you can get partial credit, but we want to get them all correct. So we got that one. Let's try another one. Okay, given 3 int values a, b, c, return their sum. However, if any of the values is a teen in the range of 13 to 19, then the value counts as 0, except 15 and 16 do not count as teens. Write a separate helper function, then fix teen. Okay, so hopefully we don't have to define this helper function, because that would ruin our sort of challenge that we're trying to do here. But this is a pretty simple idea. We just want to return the sum of these values, but if the value is 13, 14, 17, 18, 19, then they count as 0. I don't know, it's kind of arbitrary, but that's what we're doing. So what we're going to do, again, we're going to start with return. We're going to start everything with return. We're going to return the sum of, and so what we need to do is we need to take our numbers a, b, and c, and we need to just do a list comprehension, and we need to say either it's going to be the value or it's going to be 0 depending on our condition. So we're going to say something, fill that in a second, for num in a, b, c, right? So basically we're going to go through each of our numbers a, b, and c. We're going to convert them into something, either that number or 0, and then we just want to take the sum of those numbers, right? And for this, we're going to say it's going to be the 0 if the number is in this list 13, 14, 17, 18, 19, else num, right? So basically, if this number is 13, 14, 17, 18, 19, then it counts as 0. That's just what the problem told us. And otherwise, if it's not in that range, then the number should count for whatever value it is. And we just loop through each of the 3 numbers that we get as input, and we return the sum at the end. And so this works, all correct. I think that first one, the make bricks problem, is going to be one of the more challenging ones. It's kind of interesting when you're doing one-liners. Some problems can become very easy, and some can become really hard by imposing the one-line challenge. That first one just takes a little bit of logic and thinking, and I think some of these are going to be pretty quick. Like that one's pretty quick. Okay, So given three int values a, b, c, return their sum. However, if one of the values is the same as another of the values, it does not count towards the sum. Okay, so this is an interesting question. The first thing that pops into my head is using sets. We have to figure out exactly how and if that might help, but a set is a data structure that does not allow repeated values, and so we have this idea of if a value is the same as another value, it doesn't count. So that sort of gives us an idea. Maybe a set would help. It wouldn't quite work for what we're doing, because basically the idea is if we have, like in this 1, 2, 3 case, we want to add all of them. In the case of 3, 2, 3, if we converted that to a set, it would contain 3 and 2, and we want to actually ignore both of the 3's, not just 1 3. If this problem said to return the sum removing duplicates, then a set would work outright. But if we want to remove all instances of a number that have duplicates, it's a little bit trickier. It's not that much trickier. So I'm just trying to think of the basic strategy of how we want to go about doing this. You could always just do a bunch of if conditions, like a bunch of ternary operators, but that's kind of ugly. So what we could do, what I'm thinking is, just to make it kind of fun, is we could use the built-in counter that Python has, so the collections counter, and if we pass in the A, B, and C, it'll count the number of each number, and then we can say if any of the counts are greater than 1, then we want to ignore those. Or we could say of all the numbers that are in the list, we only want to count the ones where the count is exactly 1. So let's try and implement it this way. This is definitely overkill, especially when you have 3 numbers, but writing stuff in one line is also overkill, so that's okay. The first thing is we would need to import collections, which we are not allowed to do. We're not allowed to do imports, and so there is a trick. It's sort of 2 tricks in one. Basically what we can do is we can use the immediately invoked lambda expression. So the idea is that I can write this lambda expression that has this parameter called counter. So I write this lambda expression, and then I can immediately call this expression, and I can give it some sort of a value. And this is sort of a hacky way to define variables while still being in one line. But then I can use the import function, which looks like this, underscore, underscore, import, underscore, underscore, and then I should be able to just I should import collections and do dot counter. And then let's just see. Code should not use print or import or eval. Oh, so CodingBat actually doesn't allow us to use import. All right, well, I did have my idea, and I would imagine that it would work, but okay, fine, we're not allowed to import. And importing, we don't even really need to import the counter. We can implement our own sort of counter. Not the most efficient, but we only have 3 values, so it really doesn't matter. So what we can do is I'm going to construct a dictionary where the key is the number and the value is the number of times that that number appears in the list. So in this example, the first example, 1 appears once, 2 appears once, 3 appears once, and then in this example, 3 appears 3 times. So you get the idea. So we're going to make a dictionary comprehension, and it's going to be num colon let's make a list a b c dot count num for num in a b c. Right, so basically what this is doing, and if I run it, you can sort of see what it's doing, is the keys are the numbers that we have, and the values it's just the number of times that that each number appears. So as I said, in the 1, 2, 3, they each appear once. In the 3 example, the number 3 appears 3 times. Then, like this example, 9 appears once, 2 appears twice. And so now that we have this dictionary, all we need to do is we want to sum the keys that have a value of 1, right? So like in this example here, the key 9 has a value of 1, so we want to include 9 in the sum. 2 has a value of 2, we don't want to include 2, so our answer should be 9. And so now that we have this dictionary, it's pretty simple. So we're just going to do this. We're going to return, I cut that, I'm going to paste it in a second. We're going to return the sum of something for num comma count in this dictionary dot items. This might be Python 2. Oh no, I didn't implement this yet. So ignore this. This is not going to be right for a second. But basically what we're doing is we built this dictionary that I was just talking about, and then we want to loop through each of the number and count pairs, and the value that we're going to return is going to be num if count is 1, otherwise 0, right? So if the count is equal to 1, we want to include that number in our sum. If the count is not 1, we don't want to include it, we want to have 0. And so as you can see, this solution does work. We got all correct, and we got this star. I think the way the stars work are like each section has some number of stars you can get, and once you solve a certain number of problems, you get a star. I guess it's just kind of fun. And they even show us their solution. So there's their solution. It's 1, 2, 3, 4, 5, 6, 7, 8 lines. 8 lines, 9 if you count. I guess we're really not counting the functions. If you wanted to actually do this as a one-liner, you'd have to say lone sum equals lambda abc colon, like that. Hopefully that'll still work. So that still works. So if you really wanted this to actually be a one-liner, then you could just convert the function definition that they give you into a lambda like that. But I'm not really interested in that because it's trivial and you can always do it. So I'm going to continue in 1 second. It looks like, okay, my live stream was spinning a little bit on my computer for a second there. But I think we're good. So we'll move on to the next one. And as we go through, there are some people in the chat. Feel free to let me know how this is going. Any questions, any comments. But we'll continue on. So the next one is called Lucky Sum. It says, given 3 int values ABC, return their sum. However, if one of the values is 13, then it does not count towards the sum, and the values to its right do not count. So if B is 13, then both B and C do not count. And then if A were 13, then A, B, and C would not count. So this is an interesting problem. And again, if we were not trying to do this in one line, it would be very simple to solve. Very straightforward. But trying to do it in one line is a little bit more interesting. And so I'm trying to think of what we could do. And again, all these problems, since they only have 3 inputs or a couple of inputs, they can be solved with a bunch of ternary operators, and if I have to cheap out, I will do that. But I would rather not. So let's see how we want to do this one. So if we put A, B, and C in a list together, and we could just, I guess if we sort of hard code the idea that we are that we're doing this as 3 elements. Okay, so I guess the idea is that as soon we can be summing numbers until we hit a 13, and then as soon as we hit a 13, we want to stop summing numbers and we want to just move on, right? So what we could do, and we're going to use a sum as our outer function, is something for num in ABC. Okay. And so then what are we going to do? So for each number, we basically just want to keep track. If the number is 13, we want to set a flag variable that says that we should stop counting numbers. And first of all, we can't define variables. And second of all, if we define regular variables as like a Boolean variable, you can't assign it, even if we use that lambda trick that I was talking about. So if we go like lambda skip, for example, and if skip is true, it means we want to skip all of the numbers, and we give that a value of false initially, and at some point we might want to set skip to be true. Well, assigning a variable is a statement, and so we can't use it because we want to use one expression. And so a trick that we can use is we can have skip be a list. We can have skip be a list, and basically whenever we want to change the value of skip, we can just append a value to it. And when we want to check the value of skip, we can just look at whatever the last value is. So again, it's really hacky. This entire thing is hacky, but it'll work. And so what we want to do is we want to say, so if the number is 13, we want to do, so let me see if I can sort of make this a little bit more readable. So if the number is 13, we want to set skip to be true. Otherwise, we want to do 0 if skip is true, right? So if we look at the last value of skip and the latest value of skip, and it's true, that means you want to skip this number, so we set this to 0. And then otherwise, if the number is not 13 and we don't want to skip over this number, then we want to actually just have be the number itself. And then the last problem is when we do skip.append true, this will return none. We can just do or 0 like this. This is something that I talk about maybe in the Python one-liner tips and tricks. I definitely mentioned this in the balanced parentheses one-liner that I put up the other day. So basically the idea is that this will return none, which is falsy. And if we want to change this value to actually be a number, we can say or 0, right? So it'll evaluate skip.append true. It'll do the appending. That'll return none because it just appends, doesn't return a value. And that will be treated as falsy. And so this or will say, okay, this value on the left is falsy, so I'm going to use this value on the right. And so the sum will actually get 0 back. And so hopefully this will work. There could be an issue there, but no, it works. So hopefully that makes sense. It's just the idea of this like super hacky list kind of thing. I haven't really thought of a better way to do it. Python 3.8 has the walrus operator, the assignment expression. And so if this were using Python 3.8, then we could do that. I think it's using some version of Python 2, though, or maybe an earlier version of 3, but not 3.8. And so we have to do this sort of hacky thing. This was my idea, was just using this list and saying if you want to update the value, you append. If you want to check the value, you look at the last element. And it works. And so that's it. And the idea is that this answer will work if we had an arbitrary number of inputs. So in this case, we just had A, B, and C. But this would work if we had, 100 or 1,000 inputs, which is what I'm more interested in. Okay. This is taking longer than I thought. I guess when I'm kind of explaining everything out loud, then it takes a bit longer. But we're already 30 minutes in, and we're not even done. I was going to do all of these, but I don't know. I guess we'll keep going, and I'll see when my voice gives out, because I'm already feeling it a little bit. Next problem, close far. Given 3 ints A, B, C, return true if one of B or C is close, differing by A by at most 1, while the other is far, differing from both other values by 2 or more. So let's make sure we understand this one. Okay, so if B or C, one of them has to be close to A, and the other one has to be far from both A and B by 2 or more. And so we sort of have, I guess, a couple scenarios. We have that B is close and C is far, C is close and B is far. one of them is close and the other one's not far, or one of them's far and the other one's not close. I guess there's a bunch of different scenarios that we have here. But I guess what we can do is we can have, maybe we can have one condition for if one of them is close and another condition for if one of them is far, because one of them wouldn't be both close and far at the same time. And so then we could just, we could AND them together. We could say if one of them is close and one of them is far. So maybe we'll try that at least to begin with. And so to begin with, I'm going to write this on multiple lines just to make it more clear, but then I'll condense it down into one line at the end. And so we'll try this. So let's start with is close. So if B or C is close to A, so it differs from A by at most 1. So this would mean that the absolute value of A minus B differs by at most 1, would be less than or equal to 1, or the distance with C is less than or equal to 1. So if it differs by at most 1, then the absolute value of the difference should be less than or equal to 1. So that will be true if one of the numbers is close, and it would be false if neither of them are close. And then we can say is far, and so while the other one is far, differing by both other values by 2 or more. So this would either be, this is going to basically be two conditions. It's either A is going to be far or B is going to be far. B is going to be far or C is going to be far. So if B is far, then the difference between A and B should be greater than or equal to 2, and the difference between, let me write this a little bit better. The difference between B and A and the difference between B and C would be greater than or equal to 2, or we could say that C is the farther one. So the difference between C and A and the difference between C and B, right, would be greater than or equal to 2. And so this, hopefully if I did this right, is far should be true if one of the numbers is far from the other two, and it should be false if neither one is. And then we should just be able to do is close and is far. So one of them is close and one of them is far, because they can't both be, you can't have one number that's both close and far, because these conditions are mutually exclusive. Nick says, all I think about when I see this problem is Near Far by Death Cab for Cutie. Good song, good band, one of my favorite bands. Highly recommend it, but I didn't think about that, but I definitely agree with you, Nick. So that's a good one. And all you'd have to do to make this one line is just take this condition and stick it. I guess I'll just do that, right? You take that condition, stick it in there. You take this condition, stick it in there. Now we have our one-liner. That's great. I guess a more general version of this would be if one number is close to all other numbers and one number is far. I mean, I guess if you have more than 3 numbers, then it's going to be very likely. Well, I think once you have more than 3 numbers, I wonder if it's like guaranteed that this would be met, that you'd have one. There's probably some like pigeonhole principle idea or something that like once you have enough numbers, and maybe the number is 4, that it's always going to be true. Or I guess it's saying maybe they wouldn't be close, maybe they'd all be far away. I don't know. I guess I'm probably wrong there, overthinking it, but that works. Let's try round sum. Round sum says for this problem, we'll round an int value up to the next multiple of 10 if its rightmost digit is 5 or more, so 15 rounds up to 20. Alternatively, round down to the previous multiple of 10 if its rightmost digit is less than 5, so 12 rounds down to 10. Given 3 ints ABC, return the sum of their rounded values. To avoid code repetition, write a separate helper round 10 and call it 3 times. Well, we are not going to have code repetition because we are going to do everything in one line. This one should be pretty straightforward. I think our one line is going to be kind of long, but I have a good idea of how I want to solve this one. Basically, what we're going to do is we're going to do the sum. All we need to do is just the sum of, we're going to map, or I guess we'll use a comprehension. So A, B, C, right? So for each number that we have as our input, we want to convert that number into its rounded value according to these rounding rules, and then we just sum them up. So it's pretty straightforward. Now, as far as the rounding goes, what we want to do, which is pretty simple, is so if the last digit, first of all, to get the last digit, we can do num mod 10. Or I guess actually we want to do, num mod 10, remainder of num divided by 10. That would give us the last digit. And so we can say if the last digit is greater than or equal to 5, then we want to round up. And so if we want to round up, all we need to do is num integer divided by 10 times 10. So it kind of looks like division, multiplication are canceling each other out. The trick is this integer division, right? So if the number is 15, 15 integer divided by 10 would be 1, right? Remainder 5, we ignore the remainder, so it would be 1, and then we multiply by 10, and we get 10, right? I guess in this case, if we are rounding up, we want to do +1 in there. And then in the case that we're not rounding up, we just want to do num integer divided by 10 times 10. Hopefully this will work. Yeah, nice. So again, I think that explanation was a little bit brief. Let me explain again. For each number that we have, we want to consider its rounded value. So this right here will give us the last digit. We just do num mod 10. It's the remainder of num divided by 10. If it's greater than or equal to 5, then we want to round up. And with the rounding, we can do integer divide by 10, which basically divides by 10 and gets rid of the decimal. So it would sort of shift the number over by 1, getting rid of that lower decimal. And then we can multiply by 10 to shift it back and have a multiple of 10. And if we just add 1 here, it basically has the effect of going up to the next level, right? And again, to give the example I had, if you do 15 integer divided by 10, you'd get 1. Then you'd add 1 to get 2, and you multiply by 10 to get 20. And so 15 would round to 20, which is what we want. And in the case that we don't want to round, we just do the integer division and the multiplication like that. And so that's it. This one was really easy. It was one of the easiest ones. I guess if you're a little rusty on your number manipulation, it could be a bit tricky. But yeah, that's good. We got our second star. I guess, so there's 3 stars and there's 7 problems. So I guess when we solve this last problem, we'll get our 3rd star. Let's see. I'm pretty sure this is just a slightly modified version of make bricks. Let me see if I'm right about that. And if it is, I'll explain. Whoops, just that. I think this should work. We might need a okay, we need to return -1 if it can't be done. So return the number of small bars to use. Oh, I see. Okay. So just to explain why this is the same, if you read through the problem, we have small bars. We want to make goal kilos of chocolate. Small bars are 1 kilo, big bars are 5 kilos. It's the same as the bricks, right? Big bricks, small bricks. But this one says return the number of small bars to use. Assuming we always use big bars before small bars, return -1 if it can't be done. So the only difference is instead of returning whether we can do it or not, we want to return the number of small bars, or maybe we can't do it, right? And so if we take this right here, this is from what we did earlier when we did the make bricks function. This is the number of small bricks that we should use, right? And so all we need to do is we want to return, and I'm gonna have to repeat this. We want to say if this number is less than or equal to small, then we want to return this number of bricks. Otherwise, we want to return -1. And if we're going to use this expression twice, I'm going to use a lambda function just to make it look nicer. So we're going to return num if num is less than or equal to small, else -1, right? So num is just a variable that has this value in it, same value that we did like 20 minutes ago, 30 minutes ago, which again is the number of small bricks that we need to use, right, after we've used up as many big bricks as we can. And then we just say if the number that we need is less than or equal to the number of small bricks that we have, then we're good. It's just that number. Otherwise, we can't do it. We don't have enough, so it should be -1. And as you can see, we got them all correct, and we got our 3rd star. Awesome. So that's the Logic 2 problems all complete, all done in one line. We are now 40 minutes in. There are 6 viewers, which is actually more than I was expecting. I was expecting 1 viewer, which is my friend Nick, who I made watch this. But cool. Oh, now we're on to 5. Awesome. I guess I'll continue because I don't have anything better to do. And again, if you happen to be watching this, you can feel free to chime in the comments. But it's all good. And I don't know, hopefully this is interesting. I think it's interesting. Let's do some string problems. Let's mix it up a bit. Given a string, return a string where every character in the original, but there's 2. So it just repeats every character twice. Excuse me. All right, this is super easy. All we need to do is just map each string, each character in the input string. We just want to map it to that character twice. So T would get mapped to TT, H to HH, whatever. And then we just want to join all of those little strings together. So super, super simple, correct, whatever. I don't think this one requires that much explanation. I guess join is sort of taking the place of sum. And I think if I use sum there, maybe... I guess sum is expecting numbers, so whatever. It's basically the same idea, though, is that you're just joining a bunch of strings together, sort of like summing them. Whatever. Let's go to count high. Return the number of times a string high appears anywhere in the given string. I mean, this is probably cheating, but it works. I mean, Python has a built-in count function. Yeah, there's not really anything else to say about this. I don't see why. I mean, if you really wanted to, you could move through the string and look at each pair of characters and see if the pair is HI. And we might have to do something like that in some of the later string problems, but nothing to say there. I think the Java version... these Python... I think CodingBat had Java for a long time before they had Python. And I guess it's probably harder to do this in Java, so they just copied it over to Python. It turned out to be easy. It's okay. Looks like the stream is having a little bit of trouble keeping up. Hopefully the published video at the end will be okay, because it seems like my bitrate's pretty bad. I guess I'm gonna just keep going. Hopefully the video will turn out okay. So this one, return true if the string cat and dog appear the same number of times in the given string. Yeah, I mean, again, there's nothing to say here. These problems are easier than I was expecting, or at least the ones that we've seen in the string so far are very easy. Yeah, I guess if you solved the count high, you could sort of use your same code to count cat and count dog and make sure the counts are equal to each other. But that was really easy for us. Let's see. This one might be a little bit more interesting. Return the number of times that the string code appears anywhere in the given string except will accept any letter for the D. So cope and C-O-O-E count. So this one's a little bit more interesting. We can't just use our regular count. I mean, I guess we could generate every string that has CO blank E, where blank is some letter. This would be a fantastic use of regular expressions. Unfortunately, I can't import RE because CodingBat does not allow imports. And so normally if I were solving this, I'd just use a regular expression, but I guess CodingBat does not want that. So in that case, I guess we'll just do that idea that I had before. We're basically going to move through and look at all of the substrings of length 4 and see if any of them are CO something E. So let's do that. So we're going to go up to len str minus 4. Right? This I is going to be the index of the starting position. And so I think it's minus 4. It might end up being like minus 3. We'll see. It's not really that important. But basically, we're going to say our substring is going to be the string from I to I plus 4, right? So we're going to look at every little substring of length 4, and then we just need to see if it's CO blank E. So I guess we can just say if the first character is a C, and the next character is an O, and the last character is a D, or sorry, an E, and again, we don't care about the D. And if we find a match, you want to return true, and if we make it all the way through the entire string and we don't find any matches, then we want to return false. And oh, we want to return the number of times that it appears. Okay, fine. Count is equal to 0, no semicolon. Every time we find one, we increment the count, and then we just return the count at the end. And it looks like, I think this is supposed to be minus 3. Yep, that's it. So just this was slightly off the end. We want to, I is going to be the starting position of our substring. So we need to make sure that we don't go out of bounds. We don't want to go further than we want to go. So we go up to the length of the string minus 3, and this is exclusive. So it goes up to length string minus 3, excluding that index. So this just lets us get all the little substrings of length 4. It's sort of like taking a window and you're sliding it from left to right to get all those things and just see how many of them match our code requirement. What end other? Given two strings, return true if either of the strings appears at the very end of the other string, ignoring upper or lower differences. I'm pretty sure there's just an ends with function. Return. Yeah, I don't think there's a reason to be fancy about this. Yeah, I don't know. Nothing really to say here. We have this ends with function that returns whether one string ends with another string, and then we just convert both of the strings to lowercase. As they say, it shouldn't be case sensitive, and it's either one of them ends with the other one, or the other one ends with that one, true or false, whatever. I guess these string problems are really easy. Maybe this one will be more interesting. Return true if the given string contains an appearance of XYZ, where the XYZ is not directly preceded by a period. So XYZ counts, but X.XYZ does not count. I'm pretty sure we're just looking for windows of length 4. We're doing the same exact thing as the code example, but we just want to make sure that the last 3 characters are XYZ and the first one's not a period. And this is just true or false. So I don't know. This one's, I guess, a little bit boring, this problem set. So for each window of length 4, let's take a look at that particular window. And we're going to say if the last 3 values are XYZ and the first character is not a period, then we can return true. That means that we found some window of length 4 that has an XYZ in it without a dot. So you could look at this like, if this is our input XXYZ, the first window would be XXYZ, right? And we'd say, okay, there's XYZ here, and there's not a dot there, so we're good. In this example, our first window would be X dot XY. It doesn't fit our pattern, we don't have the XYZ there. Then it would be dot XYZ, and we'd say, okay, well, these last three characters are XYZ, but there's a dot there, so it doesn't count. And then if we don't find anything that matches, we return false. Oh, and then the one thing that we didn't fix is the if it starts with XYZ, because we're looking at substrings of length 4, and you know, I guess we could just say if it starts with XYZ, then we know that there's not a dot in front of it, and we could just return true. I don't think there's a point to go and like modify the code to handle that. It's sort of just a edge case. Alright, we got the string problems done. Not quite as exciting as I was hoping. I think the logic ones are pretty interesting though. We're still under an hour. Let's take a look at some of the list ones. We'll see how long these take. Maybe they'll take a little while. I don't think they will though. Count evens. Return the number of even numbers in a given array. Alright, fine. We want the number. Oh, we want the number of numbers. So we want to return the length of something, right? Just the number of things, not the sum or whatever, just the length. And all we need to do is a filter. I'll go ahead and use the filter function. You could use a list comprehension if you want. I'll use the filter function. So for a given number, we want to say we want the number of even numbers. So num mod 2. 0 and nums, right? So given a list of numbers, we want to filter only the numbers that are even. So if the remainder of dividing it by 2 is 0, then it's even, and the length is the number of numbers, and so that one's correct. Pretty easy. Next problem is called Big Diff. Brian says, yo, is this the Brian that I know in real life, or is this another Brian? We'll continue with the problem. So big diff. Given an array of length 1, an array of 1 or more ints. It's not well worded, but given an array with 1 or more ints, return the difference between the largest and smallest values. It's kind of funny because they tell you the built-in min and max functions. You could give them 2 values, but you can just give them lists. You can give it a list, and so all you need to do is return max of nums minus min of nums. So it'll just take the entire you just find the max value in the entire list and the min value in the entire list and subtract them. Super straightforward in Python. And shout out to Brian, who is indeed the Brian that I know and I'm very good friends with. So thank you for watching. How about centered average? Return the centered average of an array of ints, which we'll say is the mean average of the values except ignoring the largest and smallest values. If there are multiple copies of the smallest value, ignore just one copy, and likewise for the largest value. Use int division to produce the final average. You may assume that the array is length 3 or more. So all we need to do is just sort the list and then ignore the first value and the last value. Because it says that if there's multiple copies of the smallest value, you ignore just one copy. So we don't have to worry about any trickiness there. So all we need to do is, well, the first thing that we can do is if we do sorted nums, we can sort nums, and then once we have the sorted list, we can take a slice. So we need to take our sorted nums, put it into a list so that we can take a slice. And the slice is going to be starting at the first value and going up to, but not including the last value. So this will give us, all the values without the first and last, which will be the lowest and highest because we sorted the list. And so then all we need to do is take the sum, take the average of this, this sort of list we have here. And so we can just sum up the list and divide by the number of elements, which is just length of nums minus 2, because we took 2 numbers out. And they said to use integer division to produce the final average, so we're going to use integer division. And we got that one correct. All correct. Nice. My good friend Hari, ho ho ho. It's not Christmas. Maybe you meant yo yo yo, but thank you for watching. It's always good to have some nice people watching. Let's try the next problem. We're almost done. There's only 3 problems left, and then all of the other ones that I skipped are even easier, and these are easier than I was expecting. I think those logic ones were the only interesting ones. Return the sum of the numbers in the array, returning 0 for an empty array, except the number 13 is very unlucky, so it does not count, and numbers that come immediately after a 13 do not count. So I'm not gonna lie, I looked at this problem. I was looking at some problems before I started the stream just to sort of remember what the problems look like, what CodingBat looks like, whatever. And it took me a long time to get this problem because the 13 doesn't count and the number that comes immediately after it doesn't count. And so when you're trying to do this in one line, it's actually pretty tricky. You know, if you're not trying to do it in one line, it's very straightforward. You know, I could imagine a solution involving a regular expression that would actually be pretty nice, but we can't use regular expressions because CodingBat doesn't let us import stuff. My voice is starting to give out here. But the way that this problem can be solved was using that trick that I used earlier where you have that list. You know, you want to have like a Boolean variable, like should I skip a number or not? And you have that list, and whenever you want to update the value of the Boolean, you just append a new value to the list, and when you want to get the value, you look at the last value. And so that was the trick that I used, and so that'll work. Basically, the idea is that when we find a 13, we want to ignore the 13, and we want to mark a flag saying ignore the next number. And then when we get to the next number, if we're supposed to ignore it, we want to ignore that number, and we want to turn the flag off to say now we want to start counting numbers again. Because we only count the 13, we only ignore the 13 and the number that comes immediately after it, not all the numbers that come after it. So let's actually implement the problem. So I'll call this skip. That's what we did before. And again, I said it's going to be a list so that we can update it and still keep our one expression rule. And we want to start as false. We don't want to skip numbers initially, right? And I'm going to put this on multiple lines so that it's more readable. But basically, the first thing is if the number is 13, we want to set it to true. So if the this needs to be sum. What is this? A sum, right? So we need a sum of something for num in nums, right? So for each, we want to take the sum of all the numbers. We just want to convert each number. It's either going to be the number itself or it's going to be 0 if it's 13 or we have to skip it, right? So if this particular number is equal to 13, then we want to say that we want to turn our skip mode on. We want to skip the next number that comes after it. And then we want our sum to count that as 0. So we want to say or 0. It'll evaluate. I explained this before, but this will be falsy. Append doesn't return anything, so this will be falsy. And then the or will have the value of this whole thing be 0. So the 0 will get passed to the sum. So if the number is 13, otherwise we're going to say we want to turn skip mode off if the current value of skip mode is true, right? So we look at the last value of our skip, which will tell us the current value of it. And so if it's true, then we want to turn skip mode off because we only count the number that comes immediately after the 13, and we update it by appending false so that the last value, the new value, will be false. And then the or 0 again says that we don't want to count this number, so it should count to 0 in our sum. And then otherwise, it's just the number itself. So if the number is not 13 and we're not supposed to skip it, then we just want to count the number as itself inside of our sum. And so that works. This one took me a little while to think about. I was trying to think about looking at like pairs of numbers and a bunch of different ways of dealing with this. This solution works. And again, these one-liners are hacky sort of by design or just by the way that they are. So it's all good. 2 problems left. Return the sum of the numbers in the array except ignore sections of numbers starting with a 6 and extending to the next 7. So this is literally the same problem. It's just, well, it's a little bit different. So let's just take our code from before because it's going to be very, very similar. All we have to do is when the number is, I'm assuming we want to skip 1, 2, 3, 4, 5. Yeah, so we want to not include the 6 and the 7. So if we come across a 6, we want to set the skip mode to true, and we want to ignore it. If we come across a 7, and we see every 6 will be followed by at least one 7, so that's good. We don't have to worry about like checking the input. So if the number is 7, we want to turn skip mode off. If skip mode is on, then we want to skip the number, aka have it count as 0 in our sum. And the difference, the main difference here is just the 6 triggers it, and it's the 7 that triggers turning skip mode off. Whereas before, it was just once skip mode was turned on, it would get turned off after the next number that it saw. And so it just changed the logic a little bit, and that did not work quite. So let's see what went wrong here. So this should be 2 plus 7. My guess is return the sum of the numbers in the array except ignoring sections of numbers starting with a 6 and extending to the next 7. So, okay, so this did... Oh, I see. So we came across this 7, and we ended up skipping that 7, but we didn't want to skip it because we were not in skip mode. So, okay, so we're going to say if num is 7 and we're in skip mode. So basically, we only want to do this 7 logic if we're actually in skip mode. Because in this case, we have 2, 7. We don't want the 7. This 7 should just count like a normal old 7. And so that was our problem, right? If we're not in skip mode, if we haven't seen a 6 there, super easy. Just the 7 was the issue there. Question from my friend Hari. For the skip 13 one, what if you use filter? So I was trying to think of some ideas relating to like comparing the pairs of elements or comparing the indices of the elements or something. The problem is that you don't just filter out the 13s, but it's the 13 and the number that comes after it, which was a little bit tricky. If you look at pairs of numbers, you could see the pair that's like 13 and something, but then if you look at the next pair, it's that something and another number. So I guess if you saw a pair of 13 and something, you would just say to skip over the next pair and move on. It's a little bit tricky to like skip over stuff while you're writing stuff like this. So yeah, if the problem were just ignore all the 13s, it would be trivial, right? You could just filter out the 13s. But when it's the 13 and the number after it, it's a little bit more difficult. Now, the way that I did it is probably more complicated than it needs to be, but it's a little bit tricky because of the 13 and the number afterwards. So hopefully that answers the question, but if you can think of a better way to solve it, then I would love to see it, because I'm sure there is a better way to see it. Given an array of ints, return true if the array contains a 2 next to a 2 somewhere. I mean, this one's This one's pretty boring, pretty straightforward, but there is a nice little trick you can do in Python. We want to look at all of the pairs of numbers. So like in this example here, this 1, 2, 1, 2 example, we want to look at 1, 2, and then 2, 1, and then 1, 2. We want to look at each pair of numbers, right? And so the nice trick you can do is we can use the zip function. And the zip, the zip function will take two or more lists, two or more iterables, and it'll just take the first element from each one, stick them together into a tuple, the second element from each one, stick them together, third element, so on and so forth. And so what we can do is we can actually just zip nums with nums starting at at element index 1, which is the second element, right? And so just to see what this looks like, I think, okay, that's good. So as you can see, you can look at an example like this 2, 3, 2, 2 example. You can see that this gives us 2, 3, 3, 2, 2, 2, right? And you can look at this example here. Basically, the idea is that this nice little zip of nums and nums starting one ahead, this will give us all of the pairs of numbers. And then all we need to do is just say if any of these, if there's a 2, 2, right? This gives us, all the pairs of numbers. And if any of those pairs of numbers are 2 and 2, then that's the answer that we want, right? So zip will give us a list of numbers, a list of our pairs of numbers, and we say if this particular pair 2, 2 is in the list of pairs, then cool, we are good. And so I guess that's it. I mean, that's logic and string and list. I mean, these other ones are even more straightforward, and I think only the logic ones were interesting. Some of these were kind of interesting. I don't know. We could try logic 1 for a couple minutes and just see if they're really easy. My friend Matt has also joined the group. I wouldn't be surprised if everyone watching this right now is someone that I know in person, but it's awesome. Let's see if these are interesting. I have a feeling that these are a lot of just if statements, so I don't think they're going to be interesting, but we'll try one. When squirrels get together for a party, they like to have cigars, of course. Squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it is the weekend, in which case there is no upper bound. Okay, I mean, this is just like really basic conditions, right? So we want to say if cigars is between 40 and 60, well, I guess we can say it like this. Okay, we want to say if the number of cigars is greater than or equal to 40, so if it's a weekend, then the only thing that we care about is that there's at least 40 cigars, right? Because there's no upper bound. And if it's not the weekend, then we need to see if the number of cigars is between 40 and 60. Yeah, I mean, nothing. I feel like all of these are easily solved in one line anyways. I mean, I guess you just write if statements, but whatever. My friend Hari is saying that I Googled all of the solutions. I did not. I did solve all of these problems a few years ago. I went back and looked at a couple of them and solved them again myself. And I would just say, I hope, Hari, that you are able to solve these problems, because I think they're pretty simple. And I think that most people with enough practice could solve them the way that I am. We can, yeah, I mean, this is just another like ternary if or not if. Yeah, I don't know. Lists don't involve loops. I think this is basically it. I mean, CodingBat, they have a lot of Java problems. Some of these look pretty interesting. These like array problems, recursion problems look pretty cool. And then some new ones, functional stuff, which is awesome. But yeah, I mean, this is all that they have. CodingBat has to offer for Python. I could go in a future stream and do the Java problems. I'm a little bit out of practice with Java. I don't like coding in Java, but I would be willing to do some of them. But I guess for now we've solved all of the interesting or hardest CodingBat problems in Python all in one line, as promised by the title of this stream. It's a little bit over an hour long, which is pretty good. So I guess I'm going to call it here for this one. If you tuned in live, thank you for watching live. We had a couple of viewers come in, which is more than I was expecting, actually, so it's awesome. And if you are not watching this live, if you're watching it recorded, then hopefully you found this kind of interesting. Hopefully you'll join me the next time I do a live stream, which will hopefully be not too long after this one is done. Yeah, as always, subscribe if you want to see more. Comment with what you want to learn, what you want me to do. You can send me coding challenges, and I'll try to do them. I'll try to do them in one line if I can. You know, topics for me to talk about, whatever. And hit the like button if you like this. See you guys in the next one. Bye for now.